All right, the next thing we're going to look at is the incenter of a triangle. The incenter is where angle bisectors meet, okay? So when I look at this picture, the red lines are my angle bisectors. You can tell because each here in each corner, I'm showing that I have two congruent angles here, 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 and here, and here, okay? So that means that point P here is my incenter. From my incenter, it is equidistant from all three sides of the triangle. So remember that when we go from a point to a side, just like we said with 5-1, that we have to draw that perpendicular. So we have to make sure that if I'm drawing the distance from P to this side, I have to draw it perpendicular to the side. So these three perpendiculars are going to be congruent. Okay, now with my incenter, my angle bisectors, no matter what, are always going to intersect inside the triangle. So your incenter will always be located inside. So your circumcenter can be located inside, outside, or on, but your angle bisectors and your incenter will always be inside the triangle. Okay? Just like the circumcenter is the center of the circumscribed circle, if I draw a circle so that each side of the circle touches the triangle, okay, that is called your inscribed circle. Okay, P is your incenter, and it's the distance for, and it's the center of your inscribed circle. Sorry guys, I'm having problems talking today. What I want you guys to see is, look, if I go from here, perpendicular, here, here, all of these are radii. So like if I were to draw that same circle in here, pretending that it looks like a nice circle, all of these are radii. And so they're all going to be equal, okay? That's what these theorems are kind of based off of, is looking at those circles. It's not something that I'm going to really ask you to memorize, but it's just kind of helping your understanding. All right. So let's take a look at example 3 here. I want to know the distance from V to KL if I know that these are angle bisectors. So I'm told that JV, which is here, is an angle bisector, and I'm told that KV is an angle bisector. Okay, I only have 2 of them drawn. I don't have the third one drawn, but that's okay. I don't really need the third one drawn because I know where it's going to be, because those other 2 are going to intersect in the same spot. So since V is my incenter, because it's where my angle bisectors meet, I know that the distance from V to each side of the triangle is going to be exactly the same. So WV, this distance, and this distance will all be 7.3 because they have to be congruent. Okay? So the next thing that I want to look at is the measure of angle VKL. All right, which is this angle right here. Okay? Now, I know that, and I'm going to kind of erase this here, that this angle here is 106. I know that this one is 19. Well, because this is a bisector, I know that this angle here is also 19 degrees. So what I'm going to do is I'm going to take these 2 angles here, because this whole angle is now going to be 38 degrees, because 19 plus 19. All right. And I'm going to subtract these 2 from 180. So I'm going to do 180 minus, actually, and I can write that over here. 180 minus 106 minus 38 is going to give us the measure of angle JKL. Okay, so it's going to give us this whole angle here. So when I do that, minus 106 minus 38, I'm going to get 36 degrees. Is going to be the measure of angle JKL. Okay, so now why did I write a 3? JKL. So now I know that this whole angle here is 36 degrees. So I know again that this is a bisector, so all I have to do to get this one is cut that in half. So the measure of angle VKL is going to be 36 divided by 2, which is going to give us 18 degrees. Okay, and again, we will go over this a little more in class. So make sure that if you do have questions that you go ahead and write them down. Hope you guys have a wonderful day, and I will see you later.